So one of the ways in which, one of the ways that our atmosphere can interact with incoming energy from the sun is it can absorb a particular form of radiation depending upon the particle. And actually, as in general, as particles absorb energy, they become warmer. Okay, they become warmer because if we could see those particles, they're going faster. I love the fact that all matter is in motion. So in general, the absorptivity of a material is talking about how much in general does it tend to absorb energy. A particular form of energy is, okay, related to that particular matter. I have a couple of examples here. We talked about good ozone and bad ozone, and good ozone is O3 in the stratosphere, that ozone layer that tends to become kind of thinning near the poles during the springtime of that particular hemisphere experiencing spring. But ozone, or O3 in the stratosphere, is actually why as you go up in the stratosphere, remember, it gets warmer. As you go up in the troposphere, it gets colder. Up in the stratosphere, it gets warmer. And what's happening is this O3, these O3 molecules actually are selectively interacting with incoming radiation from the sun. They're absorbing the particular wavelength of energy from the sun in the ultraviolet region, and as they do that, they warm up. Okay, so they're kind of like a mini radiator up there in the stratosphere. Another kind of case in point is that throughout the atmosphere, whenever we have water in its vapor form or carbon dioxide in its vapor form, one of the things that it does with incoming radiation is, again, it absorbs energy and it heats up. Okay, so that's when we talk about greenhouse gases. Carbon dioxide is a greenhouse gas, and this is precisely what it's doing. It's interacting with some of the radiation coming from the sun and absorbing some of that radiation. And water, though, is another greenhouse gas. Water vapor is a greenhouse gas. So I have in my notes that this is kind of interesting. I don't know if you've noticed, we're going to talk about humidity later, but if somebody says that, the day is very humid, that means that in the atmosphere there's a lot of water vapor. So picture this. Picture it of a humid day and those little water vapor particles. Actually, one of the things that they can do is take kind of some of the sting away from the intenseness of that solar radiation headed your way. I know mugginess tends to, and we'll talk about this thing called a heat index, the fact that we feel warmer when it's humid outside because our sweat can't cool us down. But in another sense, actually when it's humid, we tend to kind of have this going in our favor where it's not as piercing hot from energy from the sun. So reflection and scattering are both types of redirection. Basically what's happening, I kind of think of ping pong balls. We have energy hitting a ping pong ball and bouncing off. Now if it bounces off directly in a direction that we can anticipate, that's called reflection. If it goes off in all directions, that's called scattering. It's kind of a subtle sort of thing. So this is showing you reflection. Okay, kind of like when you look in a mirror, your light hits the image, light from you hits the mirror and comes back to you, and then you see it, versus scattering. So they're both forms of redirection, and again, it depends upon the particle and it depends upon that particular wavelength, at what sort of scenario, whether we're going to get reflection or absorption. So along those lines, I kind of want to finish up this little section by talking about direct light versus diffused light. Now, it happens that if it happens that the energy from the sun, let's just kind of focus on visible light, if it gets through the atmosphere without either being absorbed or redirected, we call that direct light. Now, but what happens oftentimes is it will get through the Earth's atmosphere and it will be kind of ping-ponged around, scattered, okay? And then as it's scattered, it can hit off of things and then end up as light that we can use to see things. So I don't know if you've ever noticed, but if you think of it this way, if the sun's up there and I hold something to block the sunlight and I create a shadow behind that object, now I can still put put things in that shadow, and I can see those things. I'm seeing those objects not because of direct light, but I'm seeing those objects because of what we call diffused light. Light all around that's kind of bouncing around. Isn't that awesome? And that's my point here, that objects hidden in shadows on sunny days, the reason you see them is because of diffused light. There's a lot of diffused light around, thank goodness.